the right side of the array.
Mm-hmm.
Yeah, I'm gonna be real with you. Like, I asked the office hours with you, like, pick a random pivot, and I was like, what the fuck do you mean by pick a random pivot? Like, what? He said to me, I was like, what do you mean by that?
I thought that's what the partition function was for.
Maybe. Did she ever write that down? Let me check.
She gave us partition, but we don't have to know how to write partition.
Is this partition? Right here. To be honest, I don't even understand my code. Oh, fuck me.
I don't even know. I didn't even look at the partition code.
Well, all I know is like, when you do the first partition, it's gonna be here, and then you're gonna do everything else to left and right. So you have like go set that stuff in here, and you swap it, and you check, is 15 greater than 10? No. And then is 11 greater than 10? And then you can do the same thing with the right side, with the pivot. So 3 is like greater than 10, and then all that business.
Looks like merch store, but uglier.
Yeah, that's what I said. I was like, what the fuck is going on?
What are heaps?
Remember where my heaps are? I mean, this one.
Oh my god. So the heap is always just even, right?
Heap? What do you
No,
mean by
it's always it doesn't have to be even, but it's always like you're filling up all the values. It's always full.
Oh, it's always complete, right? Is that the word?
Yep, complete.
Complete? Okay.
Wait, that's AVL tree, right?
that? No, this is heap.
AVL tree is balance.
Oh, gotcha.
Code for AVL and BST would be the same, right?
No.
I'm
Is it?
pretty sure it is.
It is. The search function for AVL is and BST is literally the same thing because AVL is just a balanced version of BST.
And infinity is
I mean, I asked her in the shit, and she was like, yeah, the only difference with it is like rotations. Because AVL and BSD are the same thing.
Gotcha.
Do we have to know the rotation code?
No. She just said
No.
specify single or double.
She wrote AVL rotation, question marks. What does that mean?
No. It's like
We gotta
she
figure it out. That's
said-
what it means.
No. She said like you just have to specify whether you're doing a single or double rotation, and you have to show the result after you clean it up. That's how you do it.
Oh, like the quiz?
Yeah.
Oh.
I thought you
Yeah.
said no more than a single rotation.
No. She said it could be single or double.
Oh, okay.
Honestly. It's just you didn't have to specify direction or like details. You just have to say which one it is, which is I think that's fair, right? Like single or double. It's like 2 options, my guy. Like it's not like clockwise, counterclockwise, or anything like that.
Mm,
I mean, what else we gotta go over?
quick sort.
I was writing that. But that's not it.
If you guys want, I can explain quicksort. I think it's
Yo, you
fairly
got it?
easy.
Please.
I do not know how to do this.
Yeah.
I got you.
Please, brother.
Oh, by the way, Annie doesn't curve.
Yeah.
I think we all know at this point.
Yeah, I think she made it clear when she said, "I'm gonna fail you if I don't feel like you can pass."
Oh my god.
So like in class, like I'm surprised a lot of you guys stayed after the midterm. I'm like, yo, you cannot be saying this right now.
Okay, be real. What did you guys get on the midterm? I don't mean to pry away.
As
I got 50.
like 47,
What did she say was passing?
borderline 50, borderline like 40 to 50 ish.
Actually?
Wait, 50 is passing?
No, bro. I think she said 70 was passing.
Yeah.
Oh, 70? Okay.
No, like if you do good on the final, then you're gonna pass the class. I think.
So, because bro, someone said like only like 8 people passed, with her the passing 70 score.
Oh my god.
If she knows how you look and she like knows you come to class, and she sees you improved from your last midterm, there's a chance she's gonna pass you.
Please. Please.
Compared to the people who don't show up and she doesn't even know who you are.
I tried participating in her class pretty often.
I just hope that she doesn't put some like she gonna ask us to make the merge. Like
No, she's not gonna ask you to do the merge or the partition
like,
code.
I just hope that she doesn't go back on her word because I haven't looked at that.
Hold up.
If she asks something from LeetCode, I'm going to jump.
I hope that she stays on the outline, bro.
Yeah, no, because like if she goes into LeetCode stuff again, I'm super cooked.
There we
Yo,
go.
what if she asks us to reverse the link list?
No,
Bro, I already forgot. Like, what do you?
don't jinx that.
Right.
I thought it was reverse a link list. I still don't know how to do that.
Hold up.
Okay, have at it, sir.
Alright, so basically how quicksort is working is you have one variable here that's called j, and it's pointing to the beginning, so it's pointing to nothing.
Mm-hmm.
And then you have another variable. Actually, let's call this one I. This one is I, and then you have another one that's called j, and it's pointing to the first element in the thing.
Mm-hmm.
And let's say we just choose 5 to be our pivot.
Mm-hmm.
So what the code is essentially going to do is you're going to increment. Well, first you're going to compare 8 to 5,
Uh-huh.
and you're going to see if 5 is greater than 8,
Mm-hmm.
which is not in the situation. So what we're going to do is we're going to increment j, and then we're going to increment I, moving forward. Okay. Now we're going to compare the 2 to the 5.
Oh.
Actually, no, I lied. It's the other way around. It's the other way around.
Hold on. Huh?
No. Let me backtrack. Let me backtrack. Sorry. So you're gonna check if 5 is less than 8, which it is in this situation.
Uh-huh.
We have a temp variable that's down here.
Yeah.
We're gonna set temp to whatever j is, so it's 8.
Yeah.
We're gonna increment I, so I is gonna point to this first index.
Yeah.
We're gonna move 2 into j's position. So we're gonna move 2 over here,
Uh-huh.
and we're gonna set the temp to whatever j plus 1 is. So right here.
Oh.
So this is over here now 8,
Mm-hmm.
and then we're gonna increment j forward. We're gonna
You're
increment
moving
I
it twice
forward.
forward?
Oh well, we did it once. I just forgot to move it when we moved 8 into the thing.
Got
Right,
you.
so now-
Okay.
So now what we're doing is we're comparing 4 to 5, right? And we're
Mhm.
seeing if 4 is greater than 5, which it isn't. So
Right.
that means 4 belongs on the left side of the array. So we don't do anything to it. We just we increment j again, and then we increment I again. Right? Now we're comparing 7.
Is I always one away from, like, is it always 2 things away from J?
It could not be. Like, remember in the first case, we had them right on top of each other.
Oh.
So now j is
Really?
now you're comparing 7 to 5, seeing if 7 is greater than 5, which it
Which it
is.
is.
So your temp is going to be whatever j is. So it's 7.
Yeah.
You're going to move I forward once. You always move I forward once, and then you put in the thing. Because you don't want to change this because you just did.
Right.
Right?
I
So you
got it.
always increment up 1, and then you swap these 2.
Oh.
Yeah, so you're swapping 7 and 4 here. by setting it equal to the temp and doing it that way. And so now you increment j, you increment I one more time. Now you're comparing 1, and you just keep doing that until you're at the end.
Okay, but like it's not really sorting out the array, is it?
What happened?
You're not really sorting the array.
You're not sorting it, because by the time you're done, what's gonna happen is you're gonna be left with 5 that's gonna be in the middle, because you're trying to find out where 5's resting place is, right? So 5 is gonna be in the middle. You're gonna have it's not gonna necessarily be completely sorted.
Oh.
After this is done, what's gonna happen is the array is gonna split in 2, and you're gonna
Can you
have.
do it again?
And then you're going to do it again, but this time your pivot is going to be this one for here, and then on this side, your pivot is going to be this one for over here.
Oh.
And it's going to split until there's just one variable, and then it's all going to go back.
Oh, so it's like it's like merge sort, but not really.
Yeah, because these are not subarrays. This is just the same array that's being split into 2 pieces.
Right, I get you.
That's why you find where middle is, because you're going to do the recursive call on the left side, and then you're going to do the recursive call on the right side.
Oh, okay.
If that makes sense.
Mm-hmm.
I don't know if anybody has like any questions.
Did you mention like how in like I remember she said in special condition quicksort is like something runtime with quicksort and merge or like one is faster than other in some special condition.
Yeah, so if you if your thing was like this, right? Like this, 1, 2, 3, 4, 5, 6, and 6 was your pivot. You would be going and checking every single variable down the list, and every single variable would already be in place. So if the list is sorted, quicksort is not going to work like it's supposed to. But not the entire list. So like if it was like this 1, 2, 3, 4, 5, 6, and then over here you had like another 1, 2, 3, 4, 5, 6. Like this is the worst case for a quicksort, because half of your list is sorted, but I mean your lists are sorted in certain like parts, if that makes sense.
Right.
So how will merge sort run faster than quicksort situation?
Because merge sort will split. It won't compare everything to the pivot, so it won't compare everything in this array to the 6. It'll split it in half, and just keep splitting half in half, and then sort these subarrays, as opposed to comparing everything to 6, seeing which swaps you have to make, and then going from there. If that makes sense.
Okay.
Oh, okay. Thank you.
Also, I think I'm pretty sure for merge, you're making a new array, and so that makes it slower. I'm pretty sure.
Yeah, merge sort is almost always slower than quicksort unless your data is already sorted.
Okay, so based on her outline, the final isn't gonna be too bad. It's just like we have to remember, like, what is that called?
Runtime?
No, not runtime. No, runtime. Yeah, that's just a matter of remembering the values. We have to trace something. She said something recursive and something not recursive.
Yeah.
And I think it says the hash table thing. Like that's going to be the non-recursive object, I believe.
Recursive or non-recursive?
No. For non-recursive, it's going to be most likely hash table.
Okay.
Does that mean she's gonna give us the code for the hash table and we have to trace it?
I mean,
Do you guys
I
want to
assume
do
so.
a recursive problem?
No, I'm pretty sure what she's gonna do is like how we did it in the midterm. The first tracing the code problem was we had like an empty array, and then we're supposed to put shit in there based on like
I
the
think-
last
Count sort?
version.
Like, to be honest, I think we should just completely skip like recursion and tracing. That wastes so much time on the final. Like, they ain't worth much on the midterm anyways. Like,
Isn't it a whole question?
Yeah.
no. Like, it's only like on the midterm it was like 2 questions, and each of them is worth like 8 points. Each of them was worth 8 points in total, and there's so many parts to them. There's no point of doing them, really. You just gotta finish like the algorithm part, like know how to like explain the algorithm to her clearly, and write the code part well. And she's gonna throw some fucking freebies in like the middle, the early like the first part and the last part probably.
Mm.
Yeah, I think we still need to draw a heap with inserting and build heap.
Yeah. That's definitely gonna be a thing, or like insert or like something like BST and like yeah.
She said she was gonna put it in because we didn't do a quiz for the heaps. So, heaps and stuff, like when you're making a heap, you have to know how to do that shit.
Yeah.
I think recursion is fairly easy if you're understanding what you're like.
No, recursion is easy, but
It's a lot of time.
she does like 10 recursion call within a recursion call.
Yeah, it's like kind of annoying to follow through again.
Yeah, like her recursion is really difficult.
Did
It's
she
not
give
like-
us back the midterm?
Yeah,
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 she
she
did.
did a while ago.
Do you guys want to do the problem from the
Go
midterm?
yeah, do it. Just go for it. Do that problem.
Yeah.
I mean, it
I
shouldn't
don't-
take too long since we already did it.
Ugh. Yeah, about that.
I mean, I don't think it's. I mean, maybe, but I don't think it's smart to skip the problem entirely.
Yeah, if you have
Yeah.
some time. I mean, it's 2 hours we got, so it's better than 1 hour and.
I know, because like 16 points is still 16 points.
True.
But you waste so much time on them instead of like checking other problems. You know what?
True. True. Yeah, no, that's true.
Because I fucked up personally because I spent like fucking half an hour on recursion and I only got like 20 minutes to like fucking write codes.
Yeah, I just moved on after like 5 minutes.
No, for real,
Why would you
but-
spending half an hour?
Because
and then, like,
I thought this shit would be easy, you know? Like I thought, you know what? It's not that bad. And the further I fucking go in, the worse it gets. Like
Look.
at the first recursion call she did, it was like 5 recursion call. And I'm like, all right, this has to be the end, right? No.
Now, anytime you're taking like, you think you're taking too long, you just gotta move on to the next question.
Yeah.
Mhm.
Yo, dead ass.
So how does heaps work, bro? Low-key? Kind of forgot. It's been a minute.
Heap sort?
Yeah. I have it in my notes, but I didn't draw a little diagram for myself.
Wait, is heapify and a heap sort the same thing?
Heapify is part
No,
of sort.
It's different, I think. Is it? Oh my god, let me check my notes.
Heapify is the helper method of heap sort. It structures the heap itself.
We do
Yeah.
not need to know that, right?
You don't need to know heapify.
Okay.
You just need to know how heap sort itself works.
No, heapify is build heap. Right?
No, those are different.
No, in my notes, like from Anne's notes, like when we did the chart thingy, it says build heap in brackets heapify.
Yes. Heapify is build heap as opposed to the other choice where it's just heap by
Insert.
insertion. Yep, insertion.
Isn't heapify faster? Like it's like 34 steps versus 11 steps for that 3-layer one?
Yeah.
Yeah, okay. Alright. We need to know that, right? The time difference?
Wait. So build max heap is the same thing as heapify?
No.
No.
Build max heap is like your recursive call, but heapify is what's keeping your heap looking like a heap, if that makes sense.
Yeah.
What I understood from it was build max heap was you build the entire heap, and then heapify is you're heapifying every single little tree in there.
Yeah, no,
Heapify-
actually.
Yeah, heapify
Hold on.
works in between of build hacks, max heap.
Oh boy, give me a second.
That's the difference between inserting and then doing heapify. Because inserting does heapify all at the very end. That's why it takes so long. But when you're doing build max heap, you're doing heapify after every insertion to make sure that the heap is staying as a heap.
Oh.
Wait, can you repeat that?
So when you're doing
That's not my
insertion,
thing.
Yeah.
you're inserting items into the heap without any regard to where they're going.
Yeah.
Just in order.
Mhm.
And then you do heapify at the very end, which takes so long because you have to compare so many elements.
Yeah.
When you're doing build max heap, it keeps your heap as a max heap after every insertion.
Mhm.
Oh, okay.
So every time you insert a new element, it'll do heapify, and heapify is essentially making sure that your heap has the maximum element at the top,
Yeah.
and then everything else is like sorted, and then it'll let you add the next element. So it's in between every insertion, as opposed to doing it at the very end.
I sent a picture in the chat attached to this VC. Like, that's the heapify thing I have from her notes. Like, you know, when you see the tree thing, and like you go to each little tree and then sort that, and then you go to the bigger one, then do that. Then you get the big at the end. You get the proper heap.
If she asks to write code for the heap, it's just like a for loop, right? Because it's an array.
Yeah.
Yeah.
She won't ask us to code for that though. I don't think so. No way.
Find like min and max.
Yeah.
That's it. Wait, yo, can I get a visualization of this heap stuff, man?
No. The thing with heap is it's basically an array. So you can, if you want to find the max in a heap, can't you just return? Hold on. If it's a max heap, don't you just return the first element? That's the biggest.
Yep.
Yeah.
Yeah,
that's it.
you just
Yeah.
Oh, they're fine then. Okay, we're fine then.
The problem is if
Easy.
you have a max heap and you need to find the min.
It's just
Yeah.
You just,
It's not just a
don't you return the last element?
Yeah, isn't it the last one?
No.
Yeah, but how would you navigate to the last one?
If it's an array, you just do the. Oh right, you. Oh yeah.
Is it not just doing a for loop, bro? Because
No, but it's not necessarily the last element. It's every element is it's either 2i or 2i plus 1.
Oh, so you have to.
You get what I
go
mean?
hunting for that.
Remember when
Wait,
she
so,
was in
like-
the in class example and like
Yeah,
like
yeah.
the third part of the array was full, but like the fourth position was like completely empty.
Yeah.
Yeah.
Yeah. Oh.
Wait, so how do we find like the min then?
The min in the max heap. Okay.
You just loop through it. You just loop through it like a regular array, no?
Uh-huh.
You
Yeah.
have you have a variable called int min. You set that equal to like the first. You set that equal to like heap 0, like the first index.
Mhm.
Like the same thing
Oh,
how you would in an
yeah.
array.
yeah.
Oh yeah. Right. Just grant to the array and then find the minimum.
Yeah,
If it's
it's like the question from the midterm,
Oh.
Yeah,
kind of ish. Yeah, except with you're not finding like the average.
Right. Okay.
you just find a minimum. Once that shit is like smaller, then you gotta like set it to the new minimum if you could do the same thing in the
Yeah.
index.
And if you want to search, you just search the array and then you return what if you find it, whatever you're looking for.
I know
What did you guys do for the hash table and the graphs? Like search and find min and max.
I put it in the general chat, but I'm still not like 100% sure if it's.
I haven't even done it yet.
I've done everything but those two because I didn't like. I was stuck on it.
I don't think we have to know for the hash table. Do we have to know for the hash table the minimum and the max?
Yeah, I mean, we're not sure. She said for everything, so like I'm just assuming like she wants it for all the data structures.
I mean,
Ooh.
I'm assuming it's the same thing as search, but then the if statement is gonna be like if the current data is, you know, doing a minimum shit.
Uh huh.
Return. Like the
Yeah.
same thing with like when you do the linked list, just to find a
Mhm.
minimum.
Yeah.
Hash table is just a linked list.
But like in an array, so you gotta go do the array first.
It's an array list.
The hash table is an array.
Yeah.
Yeah, array of linked lists. So do a for loop, and then do a while loop with the something equals ahead, and then do it until it's not
Wait,
null.
so
That yeah,
So we're
that's
not
for
gonna
the
be using,
cheating
like-
one.
wait, so we're not gonna be like using any of the hash table methods or anything?
I think she's
no.
gonna give us something like a mod, like a hash
Yeah.
function, and you're gonna have to fill it in.
Yeah.
Oh, okay.
She'll be like, "Where's the collision?" and then where does this element go next if there's a collision or whatever.
That's for the
I would
code to
love
trace,
that.
right?
I'm assuming so. I don't know what else. That's what the
Nothing.
Zybooks did.
Because for code to trace, she did say hash table question mark. So most likely, like the non-recursive tracing is going to be the hash table thing, but the recursive thing could be anything. Because like she didn't specify.
It could be
anything.
the recursive one. Could be traversals too. No, like the
Yeah,
code
it
for
could be.
traversals. Yeah.
Could be. You're right.
Like
Regarding
the
hash
preorder
table?
stuff.
With the
What was
hash
that?
tables, what are the three?
So
Radix.
so the first one is closed hash. The second one is open hash with linear search, and then the third one is open hash with separate chains.
Right.
For
And
the
the third
closed
one
hash,
is the.
for the
Mhm.
closed hash, you're gonna have collisions, and it just piles up on each other. Because if a value has to go somewhere, it's gonna stay there. It's not gonna go anywhere else. And then for open hash with linear search, it's just you find an element. If there's something in there, keep going to the right, and then you can come. If you see something empty, you place it there.
Oh,
If
okay.
not, it's circular. And
Got
then
you,
the
got you.
chaining one is just an array, but each position has a linked list attached to it.
Okay, that makes sense. Wait, for the first one again, what happens if there's a collision?
If there's a collision, so like let's say you have an array with 1, 2, 3, 4, 5, and then
Uh-huh.
5 there's a collision. I'm
Yep.
assuming she'll just want you to write the collision number under the 5 because there's
Okay.
nowhere else for it to go.
But it doesn't get replaced.
No.
The 5 stays there.
No,
Yeah.
oh yeah.
Gotcha. Okay.
The
Wait,
first
what's the
one-
second one?
The second one was open hash with linear search.
That shit that goes like, oh, if it's already like something in there, you're gonna go wrap around the array until there's an empty spot.
Oh, okay.
If you guys need practice, it has the Zybooks challenges. Like it's that.
Yeah.
It's based on that.
Yeah.
Yeah, it's pretty good.
Well, I feel like I'm not able to keep swords though.
Wait, whoever said they did all like the min and max for the each algorithms except graph and hash table, can you like post like how you did it?
Yeah. Let me see, because I'm on my phone. I'm at work. Let me see.
I mean, what are the chances that that stacks and queues, right? We're gonna put something like that on it. But it's just arranging and linked list.
I mean, she said herself, everything is basically stacks and queue.
Yeah. No. She said everything is either an array or a list.
Oh yeah, true. Sorry, I'm.
Same different stuff. But yeah.
I think she said she's not gonna test us on stacks and queues because she did enough in the first exam
Please.
or something.
That is the one quiz I passed.
Yo, dead ass. She needs to test on stacks and quiz again.
Bro, I literally reviewed that.
Yeah, no, like, I need. I mean, she's testing us on stack and queue runtimes, but that's it.
Yeah.
That's the only thing.
I got a glimpse of the exam, but just the first page. It was just multiple choice.
Multiple choice.
Yeah. Like the runtimes.
Wait, what? Wait, you had the final exam already?
Yeah, but she was telling me because I have her for 343. I took her final today. She was telling me that something happened with the printer or whatever, and now she has to reprint it or something. And she like gave me a glimpse of the first page.
God damn.
Alright, hopefully there's no finals tomorrow, you know, because you gotta reprint it.
Yeah. Insider info.
There's no ink in the printer no more. No final.
Yo,
guys.
someone rob it.
Yo, dead ass, bro.
Wait,
What
no,
was on the first page? What was on the first
You said
page?
what was on the first page?
Yes.
It was just multiple choice, and it's just gonna be run times. I'm pretty sure.
Okay. Okay, I can take that.
Yo, what's on the last page?
I don't know.
What's on the middle page? I need to know. You guys want to like practice on like how? Mm,
Do you want to do the binary search tree recursion
wait,
Raj, I
what?
thought you were gonna do the midterm.
or midterm recursion?
Yeah.
My shit is bad. I mean, I can try my.
What happened? The midterm recursion? I don't have the midterm on me. Does somebody have like the problem that they could send?
She posted it. It's on Brightspace.
Oh, it
Yeah.
is. Okay.
Well, she has the answers up.
Okay.
Yeah.
I'm gonna see if I can share this page.
What are we doing now?
I'm gonna try my best to explain the.
Wait, so just to confirm, we only need 50% and 70% on projects on the final to pass, right?
I mean, I think 50 on the final. Is that a guaranteed C or no?
I don't know if
I don't
that's
know
a
if you're
guaranteed C, but like I remember the syllabus saying something like if you don't have a minimum of 50 on the final and 70 in the projects, and like no matter like what everything else averages out to, you're not getting a C.
Right.
She's not the one grading the projects.
No.
Learning
It's
commons.
it's the learning commons, bro. Yo, someone tell them like give us 100, bro.
We got the why me shit beginning, all of that, and then all of the min. So we're gonna begin with y.
So much.
A is the 3 and B is 5. Is B equals 0? No. And then we're gonna go to if 5 modular 2 equals 1, which it is. You're gonna do the return y again. So you're gonna go to this shit y. And so now still A has not changed, B has changed since in the original code 5 minus 1 equals to 4. So it's 4. Is that equal to 0? No. Is that equal to is that modular? That shit don't work. So then we're gonna go to temporary, which is y. Keep the A, which is 3, and then 4 divided by 2, and then you're gonna get y 3 2. And then you go check if B
For
equals
that-
0, no, and then do that again, check if it, and then do temporary again, which is y, and then 2 divided by 2 is 1. And then when it does do that, B is not equal to 0. And then finally, 1 modular 2 equal to 1, which returns 3 times y. And so when 0 equals to 0, it returns 1. So this y over here returns 1. And so in this statement, 3 times 1 equals to 3. And so temporary of y comma 2 is going to equal to 3. And then 3. And so then we'll go down, continue this line, this specific code piece. So temporary times temporary equals to 9. And then we're going to go back up. And then we're going to have the temporary. So this temporary equals to 9. And then temporary times temporary equals to 9 times 9 equals to 81. And we're going to pop back up all the way back to our original code, which is return 3 times y, which y 3 comma 4 equals to 81. And the final code, and you know, not the final result is 243 for this whole entire system out that print, which sucks because this shit was ass.
Yo, dead ass. I'm having a fucking headache looking at this shit.
I wanted to jump on this.
For
Wanted
this
to this
question,
test.
I did it again, and it was way easier than we made it. Like you have to trace the calls all the way down to the
Yeah.
base, and then you work it backwards. That was the trick. I think
No, I
a
just
lot of
didn't
us
like
just
the-
gave up halfway or something.
I didn't like how she just gave us a table to do it, because I would rather do it like this way. Because
Yeah, I think like if she just left the space blank, people would have done better.
Yeah.
the table fucked me up. I was like, fuck
Yeah, the
this.
table fucked me up too.
And then we got this other bullshit. So,
Yeah, I
blah,
didn't use
blah.
a table, and she just wrote all right next to my answer.
Wait. Did she give you full credit though?
I got it correct, so she gave me full credit. But I had like everywhere around the table, I had all the diagrams, but I had the entire table blank.
Nah, it's fucking
Oh
crazy.
wow!
Yeah, bro, I wanted to do without the table, but I was afraid she was gonna take off points if I didn't use a table.
Yeah.
Yo, that ass.
Nah, fuck the table. Honestly, with recursion, the table is horrible. Do the
Yeah, you
splitting
just
it and then
do it
going
on your
backwards.
own. Like it's
Yeah.
much easier.
Mhm.
I just draw each call and I make an arrow down.
Yeah, this is how I do my shit. But we do the same thing again. B is equal to 3, B is not equal to 0. B modulo 2 equal to 1, which it is. So we're going to return that, but we're going to go to the recursion calls first. Why? Because the reason why this becomes a 2 is because of the original code again, which you minus it by 1 in that line. And then is 2 equal to 0? No. 2 modular is not. And so we're going to go to temporary, and then we go to another y. 2 divided by 2 equals to 1. Is 1 equal to 0? No. 1 modular 2 equal to 1. Return y again. So when you hit this y, when you finally hit the base case of b equal to 0, it finally returns 1. 5 times 1, so that equals to 5. And then it goes back into temporary, which equals to 5. And then we return temporary times temporary, so 25. And then we go back up. And then finally we returned 5 times 25, which equals to 125. So that's the correct answer for these two system out that print. I don't know, man. This shit.
It's
I don't know.
ridiculous.
Waj, can you do the count sort question from the midterm?
Which one?
The count sort from the midterm.
Oh,
Wait,
Yeah, which problem is that?
That is number 2. Part 2.
Number
part 2.
Yeah. From the midterm, yeah.
Is it this one? That is the top one that I'm doing?
Wait, is the count
Yeah,
sort
yeah.
the bonus question where she's like, oh, O of n, you get this amount of points, and log of n,
No,
you
no,
get
no. The count sort was the tracing code part 2.
First one, yeah, okay. Yeah, I got the code down. N equals to a dot length. The length is 10. Pretend that shit isn't there. It's like it was just empty, right? The color shit.
Wait, this shit doesn't print, right? Like it runs an error.
We're not printing anything. We're just doing shit for the array. We're filling it out. 'Cause, like,
Okay.
when the midterm was just like empty. I mean, well, you're given array A, but array C is empty. And so n equals 10, r equals 6. Then go to the for loop up to 5. And so basically with this for loop, you're setting everything in array C to be 0. And then for the second for loop up to 9, so when A index 0 right now, we're only looking at the black one right now, the black information, so we got 2, right? And so at index C index 2 plus plus. So right now I just wrote down like 1 right here to show that okay, we're counting that, and then we'll go to the for loop until A index 1, which is 5. So at index C, I'm gonna add a 1 there, and we're just basically doing the same thing with all of that. And so we got 3 next in array A, and so at array C index 3, we're gonna put a 1 there, and then we'll continue doing that until we count all of it in array A. and I'm gonna add. And this is how I just did it. I just added up all of it. I just helped me out to envision it better. So index C right now would be 1, 0, 3, 1, 1, 4. And then we get into K. So up till 5 till J equals to array C index 1. And so I did some code over here. So I is equal to what? 0. So at index 0 of C right now is at 1. So till 1. So A, we're gonna change the index. We're gonna change A index 0 to 0. So that's updated, the green one. And then we'll go up to 1. K equals to 1 because of K plus plus. And then I up to 1 because we're going to go into another. We're going to finish that code in there. And so when J equals to, when J equals to 0, this for loop, this doesn't make sense up to 0, so we don't do anything with that. And then K is still 1 because he didn't do anything with that for loop. And so I equals to 2, J equals to 1 still, and then index 2 of the array C is equal to 3, the data, and then all of that business. So we're gonna do this until 3 times. So we got, but this is a for loop, right? So A K plus plus equals to 2. We're gonna do all of that, and we're gonna do it at least 3 times. And so now K is gonna equal to 4 since K plus plus. So I equals to 3, and then all that funny business. And then you see, you only print it up to 1, so you only print 3 once, and then K plus plus. So K equals to 5, I equals to 4, and so the same business again until you only print it out once 4, and then you K plus plus 6 equals to 5, I equals to 6. I equals to 5, and then you see it into 4, so 1, 2, 4. So you print it out 4 times. Don't matter. That K wasn't there. I just kind of wrote that out by accident. That K in the first one is supposed to be array like A. So that equals to 5. And so this is the correct output of what you're trying to do. You're like sorting it out, and like you're sorting it out how many times the 2 has been printed, 5 has been printed, and then array C shows how many times it's been repeated. So yeah, that's what I did for the tracing code. Hopefully that makes sense or not. I don't know. That's how
No, you got it. It just feels kind of. I feel kind of cheated. Like, tested us on leak code, even though like most of us haven't touched leak code, and it's like, hold on, this is not a leak code class. This is a data structures class.
A lot of leak code is data structure, though.
Fair point.
The leak code, I messed up with define someone. I don't even know what that was. But yeah, I didn't rewrite any of the code for that though. I was just retracing it. But yeah, there we go. That's
A lot of
all I
leak
got.
code is data structures. That's fair. But like she didn't prepare us for those questions that she gave us. So you can't expect people to do those questions correctly when you never taught them.
Right. Like, I would have understood if she went over like some common leak code things in class and was like, okay, this is what we expect. What I expect you to do on the test. I'm like, okay, she taught us leak codey stuff, fine, but like, you know what I mean? It's such a big gap between what she taught and what she tested us on.
Yeah,
I think.
Yeah, like especially with the recursion tracing shit, like other professors, like their fucking like recursion is like, okay, you gotta do this, you gotta do this, you gotta do this. Her recursion is like someone fucking like shit shit on the fucking like on your plate or some shit, like because no one write recursion like this. Like it's so fucking messy. Like other professors' recursion problems is like, oh, you got like it divides the work into like this little parts. You gotta understand how that works, right? Like, it's not like you have to go through like 2 recursion call and you have to figure out what the other 2 recursion call do. Like, yeah.
is insane. It is.
Other than the reversing, what was it? A linked list or other than that, there was no other leak code though.
Yeah,
there?
the consort was kind of leak coded because we never even talked about
The
consort in
two-sum
class at all. No.
The
Yeah.
two-sum question.
I think the reverse list was the hardest one. Probably.
I think that one, I got that one wrong, but the answer to it was just you just the helper method was just the reverse, like you just make a method called reverse, and then call it on the head or whatever, and then call that in your main method.
No, but like you're supposed to. I kind of wrote an essay, not an essay, but like I basically wrote out in words how I would reverse it, and I got partial credit. It was just like you make a dummy node and then traverse the linked list, and then you just reverse the direction of like the two nodes it's in between. Like you flip it and then you move on, then you flip those. You just keep going down the list until you run off from the end, and then you reverse it. But like I wrote an essay for that. Basically, I didn't code it at all. It was I was like, oh, first you do this, then you do this, because she said pseudocode is okay, and like you can describe stuff. So I was like, okay, let me know how to see this and just write it out. Pengi, this was the linked list one, like reversing a linked list. This was, I believe, was this after the recursion? It was after the recursion question, right?
Wait, which class? Are you the 915 or?
10:45.
Wait. Look at the same exam. Wait, when did we do the reverse link list?
What, that was on your exam?
Wait, what? You didn't
We
get
had, yeah, we didn't get that.
No,
Bruh.
that?
no, I'm
Wait,
the
get
1045.
get what?
Like reversing a linked list.
What?
Yeah, that
Yeah.
was the second coding question, huh?
Wait, let me pull up my exam because I don't remember
Yeah.
doing that.
It was the exact question was write a recursive method, print R in the linked number list class to print the list in reverse order.
Yo,
Yeah.
You will need a helper method.
Fascinating.
Wait, this is for part 4? Writing
No, it was part 3 for us.
It was the code to write. It was the second question.
Yeah.
Oh, yeah, I see it
Oh
now.
yeah, no, I see it. Yeah.
Our apartment. I'm the brains and he's the wallet. The first thing I wanted to do was the
I
fireplace.
still have no idea how to do it, to be honest. She posted up the notes, like the midterm answers, but I haven't looked at that specifically.
It was the second question of part 3.
Yeah.
From deck. Or place the candles on the fireplace.
Did she say how long this one was gonna be? Because we have 2 hours.
My boyfriend and friends.
All similar length, right?
Who's watching TV or something? I hear background noise.
I think someone's not muted.
I honestly
Pistachio.
although it's more of how I grow.
Pistachio, yeah.
Pistachio in my ear. Thing.
Yo, Mr. Pistachio.
Not yet.
Ah, shit.
Hold on, I'm gonna rewrite the hash. I think I wrote it incorrectly. I might put the new, better version of it.
God. Okay, I think it's not. Okay.
So just the sorting algorithms, run times for all the data structures, and all the find, min, and max methods, and search methods for all the data structures. That's it, right?
Mm-hmm. What's looking to be the hardest right now?
I think
Recursion, probably.
no. I think honestly, I think one of the coding questions is gonna be harder than recursion.
I feel she's gonna make it tricky.
Fries.
She's not gonna just make it like what she said it was. I don't know.
Bro, we're in the.
I mean,
trenches right
probably because
We are in the trenches.
apparently she threw curveballs for like the 343's exam.
She didn't. I don't know why people keep saying that. She just didn't ask a question, and then you had to compute it on your own. So people thought that was the curveball.
Oh, okay.
No, but she was really fair with the 343 exam. I think she'll be fair with 313 as well.
Okay, I'm gonna post up the new one. Like, yeah, the one with hash tables. Updated.
Can we cover the code for like building a heap
Yes.
and like the insert too? Yeah.
Oh yeah, build set, build.
Build heap, yeah.
She's gonna ask us to code that.
I don't think so, but I think I think it would be like, I don't know, good to review it.
Hopefully.
I know she is gonna ask the
Eh.
builder. Fuck. Well, my brain is really mush. She's gonna ask.
I thought she was gonna make us draw it.
No, it just says illustrate some part of the algorithm.
Oh.
It says understand the algorithm for merge sort, quick sort, heap, illustrate some part of the algorithm. Then it just says heap insert / build heap.
Yeah, the heap insert / build thing was gonna be the quiz that we were gonna have last week, and
Yeah,
the
that-
illustrate, yeah,
That was just supposed to be drawing. That's why I'm
yeah.
Yeah.
And then I think the illustrate the algorithm thing is the screenshot I sent. It's like the fourth picture. I'm pretty sure it's just knowing the code. I got it from the Zybooks. I'm
Oh, shit.
pretty sure that
That's-
I'm pretty
that's
sure
credit.
I'm pretty sure that's all she wants us to know for the coding for the sorting algorithms. I think. I'm not sure.
Who got the heap? Cause I don't. actually don't have
T
a-
Graves sent it.
No, like how does it work?
Oh, okay.
I think Snorlax know how to do heaps. He was
What do
teaching me,
you mean, bro? Stop capping.
or B stats. He was teaching me earlier too.
Well, Watts, can you go over how to get like insert and heap?
With Heapify?
Yeah.
Okay.
Well, are you gonna do a 320 review tomorrow or not? Anything?
320 tomorrow? Maybe.
Because I was thinking of doing some sauce for 320.
You're in Ribos?
Yes.
Okay.
What the?
Maybe it depends on what time you guys are on.
Evening. Oh, definitely evening.
Evening.
Yeah, because people have 2 exams. Look, a lot of people have 2 exams tomorrow.
Yep.
Hold on, I have a reaction image for this.
So
Go for it.
let's make an array.
All right.
So I don't know why my shit is like lagging. Hold on. Sorry, guys.
Yo, the test is in the same classroom, right?
Yeah.
Okay.
It's at what, 11, right? 11 tomorrow.
11, yeah. We also have the bucket sort. Remember that like mod thing. And then like you only get odd thing. Oh, I remember something like bucket sort.
So we're gonna first add 12 as our top element. 13 is greater. Actually, no, that's a lie. We're gonna go to the left. We're gonna add 13.
Mm-hmm.
We're going to the right. We're gonna add 20. After adding 20, we're gonna go to the left of 13. We're gonna add 21. We're gonna go to the right. We're gonna add 17. Left of this is 8. Right of this is 3. Then we're gonna call. You guys want to make it a min or a max?
Man,
Max? Okay.
Okay, min. So smallest digit on top. So we're gonna check to see from the right side. So from the last node that we entered, is 3 smaller than 20? Which it is. So what we're gonna do is we're gonna swap these two elements. So now we have 3 here and we have 20 down here. Now we're gonna check 8. Is 8 smaller than 3?
No.
No, it's not. 17 and 13. Is 17 smaller than 13? No. Is 21 smaller than 13? It's not. Next, we're gonna go back. So we've completed this layer essentially. We're gonna go up to the second one now. We're gonna see is 3 smaller than 12, which it is. So we're gonna erase that out. We're gonna swap them. So now 3 is here. What was here? 12. So 12 is there. Is 13 smaller than 3? No, it's not. We're gonna go back. Is 21 smaller than 13? No. Is 17 smaller than 13? No. 20 smaller than 12? No. But 8 is smaller than 12. So we're gonna take 8. We're gonna move that up. 8. And we're gonna have 12 here.
wait, so we're gonna do it till like
sorry.
everything is in its place, right?
Correct. It's until everything is in its place. So 12 moves down here. So this is your min heap. You have 3 at the bottom, and then everything below it is smaller. To put it into the table, for the like let's say this I equals to this is node 1. You're gonna put 3 at the beginning. The right child of 3 is 2i plus 1. So since 3 is 1, so 2i plus 1 is the third position. So it's going to be over here. So the right child is going to be 8. The left child is just 2 times I. 1 times 2 is just 2. So in the second position, you're going to put 13. For node 13, for the left side, it's 2i. 13 is in the second position. So 2 times 2 is 4. So 21 is going to go here. For the right side, 17 is going to go, I believe, like right here. And you keep doing that, and you put them into the array. For this, all you need to know is left is 2 times I, and right is 2 times I plus 1.
Wait, so this is build heap, right?
This is build heap.
Alright.
Wait,
Wouldn't
what?
the 17 go after the 21?
Yeah.
I feel like that's like isn't that
Yes, it should.
Wait,
So
index 3 is starting at index 0, or
3 is starting at index 1.
okay.
If it was 0, then
Yeah, exactly. That's what I was asking.
I thought you just go left to right from top to bottom. That's what I do.
yeah, that's basically it.
Is that or am I tripping? Is that wrong?
you go to 3, 13, 8, 21, 17.
12 and then 20. Yeah, that's how
Uh-huh.
I place it in a race.
That's how I did it too.
But this is good to know because in case you have to write the code for it, this is no, not node, but this is how you would insert them in.
Basically like this min heap is basically like a reverse of BST, because with BST, or not reverse, with BST your left child is always like left like lower than your right child, but in this case your left child is always bit greater than your right child.
No,
No,
so
it's with the parent. It's with the parent.
Yeah,
Oh,
The parent is always less than his child nodes.
Yes.
Yeah, in the min heap for now.
okay.
but
And
it's
max heap's the opposite. Yeah.
yeah, we're referring to both though. We're not necessarily saying 13 is bigger, so it's on the left side, and 8 is smaller, so it's on the right side.
Yeah, it
We're
doesn't
ju-
matter like which is on the left or right.
Yeah, we're just saying that these two are guaranteed to be greater than what's on top in a min heap,
Okay.
and these two are guaranteed to be smaller than anything that's below it.
Hopefully she doesn't ask us coding question regarding to this.
Waj, could you also go over the heap sort algorithm?
Yeah, one sec.
Was this one min heap?
Yeah.
Does somebody have it written already?
The heap sort?
I have the pseudocode for it.
Yeah. Me too, but I'm not playing it. I just wrote it down. It's just
For
build
heap,
max
the
heap.
pseudocode, you call build max heap on the array, and then you have a for loop from I down to 2, and you're just doing a sub I, delete it.
Let me see if I can find the code and then I'll just explain it.
What are we doing now? I just realized. Really got quiet.
Oh, yeah, I don't know what we're doing.
We're doing the
Yeah, I can't find the code for it.
with the pseudocode?
No, not the. You guys want the pseudocode or like the code?
Code.
Yeah, the code.
Yeah, the code.
Shit, will she let us pass? We write pseudocode.
I mean, she said. I mean, that's what I thought too, right? I just want to understand it because I don't understand heaps for it.
She will. She said if you write like those 3 lines, they'll give you the points.
Yeah. We'll be fine-ish.
Hey, hold up, I was gone for a second. I'm pretty sure I sent the heap sort code in the screenshots I sent. It's one of them. It's just the algorithm part though. It's not the like the helper functions. I'm pretty sure that's all she like wants us to know.
Mm-hmm.
Wait, so who's in the 915? Is there anybody here with something?
Yeah, I'm on 950.
Yo.
Guess you guys still got some extra time.
Did she give you like she actually said she gonna give you a bonus question?
One more part extra for special.
Fuck, man.
Must be nice.
Like extra credit or like what?
No, not extra credit.
Oh, so you said another question.
I
Yeah.
think 915's exam is just gonna be a little bit longer, isn't it?
Yeah.
Did she say anything about that or no? Just like she just noted there's gonna be extra questions.
Yeah, she's be no extra question. One part different from the 10 to 45 class.
That's good. I mean, it's not like super different.
True.
I mean, depth first search. We're just drawing that out too, right? Oh, actually no. When you know the code, we already have like the recursive code, like it's not visible. Then what the fuck is bullshit, man? She like taught at the end of like literally like 4 days ago. Hope that depth first search is not like super like mega heavy.
Mm-hmm.
What do you guys need on the final to pass?
Enough.
What was that?
No
Enough.
idea. Wait, so
50.
how do we know? I mean, I got
Actually, yeah.
I got a 64 in the midterm. I don't know.
Feel like
I mean, you need at least a 50,
Pass.
or she's
That
gonna
doesn't
fail
help.
you, regardless of
Yeah.
what you got on anything else.
Okay.
Yeah.
So at least a 50. All right.
I asked her if I get a 70. She's like, yeah, maybe I'll pass you.
Maybe.
alright. I need an 80. Like guaranteed passing C would be an 80 for me. I just did it with a grade calculator. Like I'm assuming that like, I get like maybe an 80 on my projects, and then just doing.
Yo, bro, literally, someone just told the learning comments, yo, give us 100, yo. Like, come on.
I thought
Yo,
the projects were just like pass or fail.
The
Some
projects
people
are graded
in
by the
here
learning
work at the
comments.
learning commons.
What?
Well, I thought she doesn't even check projects.
No, she said she gave it to the learning comments.
Isn't
Oh,
there someone in here that works at the learning commons? Or like knows someone?
please.
This is crazy, Brad. Like, we did the projects when, like October, November.
Mm-hmm.
It's like,
I'm just so glad she didn't give us the last 2 projects. I would have been dead.
Yeah.
Yo,
yeah,
that
that's
ass.
right. What's your guys' quiz grade?
D average.
I think it's B plus.
How much have you had?
4.
Okay.
Wait, someone got 4?
No, I think he asked 4 quizzes. We had 4 quizzes in total.
Oh,
Okay, listen, I'm asking hypothetically, out of the 4 quizzes we've had, I may have passed one. Is that bad?
Wait, bro, I cannot.
What did he say?
Bro,
What?
yeah,
Yo, what's going on with your mic, bro?
Yo, mad
It sounds like you're underwater, bro.
Yo,
I
are you
said-
drowning? You good?
But I'm saying that out of the 4 quizzes, I only passed 1.
What?
Hell no.
Oh my
No, what?
That's not that bad.
Wait, what do you mean you passed only 1? Like, you, like, got a 0 on the rest?
No, the other 3 I got Fs.
Oh.
Is that
Did you
why
average
she
it? Damn.
she looked at you? She was like, "What happened?"
I mean,
Damn.
quiz is only 15%. I think you just need to do good on the final. I mean, you just need a 50 on the final,
Yeah.
bro, and you'll be fine.
Yeah. Just get the 50. Get that like passing grade, basically.
Yeah.
See, it's degree, get degrees, bro. Come on.
No, 'cause I'm gonna be real
I
with
can
you
do a
guys.
50.
Like, I went to office hours, and there's a bunch of people, and I remember seeing like one time someone bought her actual coffee. Was that any of you guys? Like dead ass?
The who's kissing her ass?
Yeah, that's the method, though. That's the method, though.
Like dead ass. Like, no, he left, and I was like, oh, he's gone, and then I could ask my question, and then bro came back with a coffee, and I was like, huh, bro, who, what?
I might get her a dozen donuts tomorrow morning.
I'm like, who are you, bro? Do I know you?
At this point,
I mean, I'm not gonna lie, I haven't gone to class since the last quiz that we had in person.
no, it's crazy.
That's crazy. You know what, guys? Let's all attribute
You're not the
$1.
only one.
Class
I'm
is
just
not even
saying.
that useful, bro. I'm being
That's
honest.
true.
Most of the time, she doesn't even write code. So
True.
That's true. She just like go over it, like oh whatever the topic is.
Bro,
That's
it's all
it.
in his iBooks anyways.
Exactly.
For real.
Waj, do you think you can do the graph code?
For which one?
Like all 3 of them?
Yeah.
Like all 3 of the graph representations?
I'm so cooked for graph.
I think most
Wait,
of us are.
Wait, which graph specifically?
Like, so there's 3 representations. She wants us to know, like the search, find min and max on all of them. So if you want to do I think the hardest one is the adjacency list with the valence. It's like the
Yeah.
array of lists.
no way she asks us to do like a specific one, bro.
I don't know. She said to
Hold
know
on,
everything.
This is the first time I hear about this. Hold on.
No.
What?
Yo, wait, what are you?
Oh yeah,
talking
we're
about?
cooked.
Yeah, we
What
are
are y'all
cooked. We are
talking
cooked.
Bro, I thought we just need to know one representation.
I don't
Who
know.
told you that?
Section what?
Last day, bro, like on the 12th, like she went over that.
Bro, she either accepts it or not, bro. She gotta accept it.
There's three hash tables and there's 3 graph representations.
Hell no.
But
I
what
think
do
you
you?
gotta know the runtimes on them too.
What graph?
Huh?
Out of here, bro. Fuck out.
Bro! Okay, so there's 3 graph representations. There's the matrix, there's the adjacency list, and there's the adjacency list with valence.
Oh,
Oh shit! Oh yeah, I know what you're talking about. Okay.
Oh,
okay.
that one's
Yeah.
okay. That's not
okay.
bad.
Scared me.
Oh, the one she
Yeah,
went
I'm
over
saying,
class,
like-
right?
Yeah, she went over
Yeah.
that in class.
Yeah.
But the thing is, she went over it in class, but didn't even give explicit code, really. She was like, it's either like a for loop or an array. I mean, a for loop or a while loop.
You barely give us
Alright,
calls.
so we just
Just
guessed it,
gotta
basically.
guess. Yeah, we have to guess.
Okay.
Oh, fuck.
Wait, do we know where that PowerPoint is? I mean, not PowerPoint, PDF is under specifically.
Did she even post it?
There's a for graphs.
Yeah.
I don't think she posted the graph one. I was looking.
The Tuesday?
Yeah,
No,
it's
no,
cooked,
no.
bro. It's cooked.
Code for it.
No, knowing her, she's gonna post it tomorrow morning at like 8 a.m.
Hi
I posted
guys.
it. Just scroll up.
Actually, she's gonna post it after you guys did it first.
No, I
What's
sent
up?
it in the chat. I was
Oh,
in
you sent-
class that day. So
Oh my god, you're a godsend, bro.
I copied. You literally asked for it in the beginning of the call.
Yo, did you not see that?
Oh yeah. My bad. I forgot.
You even liked the message.
Holy shit, bro. It's okay, no worries. We got it. We got it on lockdown for real.
Oh, this code right here with the find in and the find max. Is that what you guys are talking about?
I don't know what you were looking at.
I'm looking at this right here. Hold on. Are we talking about that?
Are you sharing your screen?
No, I sent it in general.
Oh.
That's for BST. Wait, what are we
No,
talking about?
it's here. Let me reply to it.
It's the paper ones that they posted. The one with the the 2D array.
The one I just replied to.
Yeah, that's the map. That's the graph.
Yeah.
Yeah, if anybody wants to stream and explain that.
Yo, what the fuck is this?
The microphone is really easy though. It's just like
The first two are arrays, and the last one is an array of lists. It's like the same as the hash table.
one's an array. The second is a list. The third is an array with lists, or an array of lists.
Oh, okay. Wait, so the first one's an array, second one's an array inside an array, or with array, and then third one's array with this.
The matrix is a 2D array. The digital list is a list. The third one is an array of lists.
Okay.
The other one is a hash table.
But it's an array with it's an array of lists, basically.
Yeah, that's it's not. Oh no,
Yeah,
that's that hash table. Yeah. So just remember, like chaining hash table is the same thing as adjacency list with valence. That's not bad. Like we would have like. Well, I'm assuming that adjacency list is like the same thing as hash table with chains.
I can explain this third one. This third one is it's fairly easy. I don't know if you guys want that.
The linked list one?
Yeah.
Yeah, I think we should go over that. I think that's the hardest one.
That's the hardest one? Okay. We're looking for a specific element. Yeah, so we're looking for 4 inside this. And what we're doing is so it's a public method. It's called search. We're given integer 4. And we're given integer 4, and then we're given an array.
Wait, was she asked us to like code search method?
I'm pretty sure, or at least understand how to do it.
Okay.
So what you're doing is just doing a for loop to iterate through this array that you're given. So I is less than array dot length I plus plus. And in this, we're doing a while loop. Actually, before that, I'm gonna make sure tomorrow don't in any of like what are they called, linked list code, don't move the head. So
Yeah. You say if you fuck up the head, she doesn't like it.
So while current dot next doesn't equal null, an if statement. So if current dot data equals this is a boolean.
Is this search for a hash table?
You don't write method, right? You just write public.
Oh no,
boolean.
yeah. This is public boolean. This code isn't like completely correct. Like this is not how you initialize it. Node current equals, what is it, like new node?
No, you just put head, because if the head is passed in.
Oh yeah, if the head is already passed in, then you can just set it to head. If current dot data equals to this would be a variable.
Is this the graph code or the hash table?
This is the fourth. I mean the third. Your third page.
Third page.
The code isn't exactly the same, but this is essentially what it's doing, because you're searching for inside.
If it's hash table, then cur should be array and then the I dot head, wouldn't it? Because the nodes are in each of the indexes of the array. So
Correct.
array
Yeah, so or over here it would be I dot
head.
While current dot next isn't null, if current equals data, return true.
And then else return false.
Yeah, so return true there. Close this out. Close this out. And
Wouldn't it be the array sub I dot head for the current?
Yeah, it should be that.
Right here.
Yeah, array sub I dot head.
Because first you're looping through the array index, and then you're looping through the linked list in there.
No, head is outside. Dot head. Because the linked list is in the indexes. Yeah, like that.
Array I dot head while current dot next. Is it null if true?
And then you set current to equal the next current, because that's just gonna be an infinite loop.
Yep.
Yeah.
So, yep. Current equals
Above. Sorry, I'm like nitpicking. Above return true.
above return true? No, you would compare the data first, no?
Yeah, you would, and then below it,
Wait,
should
wouldn't
be.
it be after the if statement?
The
Yeah,
return
after
is
it's-
outside of
Yeah,
the loop.
above return. Because if you're returning, it won't be able to run the code after that.
No, I mean like after the whole if statement.
Yeah,
the
yeah,
return
yeah.
is
Like
outside
here.
of the if.
Yeah,
Like there. Current.
Equals current dot next.
Yep.
Okay, so like basically you just so in the for loop you grind out the node, and in the while loop you go to the list that the node is attached to.
I
Yep.
think
Oh.
for the current, shouldn't it be array sub I dot head dot next? Or am I
Oh.
tripping?
Nah.
Because the first
No.
index, the
Nah.
No,
first
'cause
index.
it's already inside the index, so it already has that head. So that would be the current node. So it's already inside that linked list.
But the isn't the first position in each of the linked lists null?
No, the first position. Wait, no. Yeah, it is no, but like, that's why we have a dummy no. So
Yeah, that
Wait, just to clear something up, are we doing linked list here or array?
link list.
Both. Oh.
But
Because if you're passing in a linked list, then you would set the thing pointer, right? But if it's an array, wouldn't the head just be array of 0?
I'm so confused.
No, I don't think so. I think array of 0 is the first element in the array. But I don't know if there's like a dummy head node for this one. Like I think you're right on that, but I don't think there is one for this case. Like the head would be the first element in that
Like in terms of an array, that's what I'm saying. Like, the head would just be the first, like 0, right?
Yeah, I think
mean,
head would
head is the first one for the indexed array. You get me? Like
Watch,
Head
in
would be
each of
the
those
pointer.
boxes, it's null, right?
Which box? Up here or
The
down here?
array, yeah. No, up there.
Up here?
The index.
Each of those would be null, right?
Why would they be
It's
null?
the beginning of the
Yeah.
linked list.
No, they won't be no.
No, I think each of these would be head.
Fellas,
is-
quick question: are we using master theorem on this exam?
She said to know it, yeah.
I mean, she said know it, but she said there won't be any specific questions on it because she said
Okay.
we should know already what it is, but I don't, so I don't care.
Mm-hmm.
I guess it wouldn't hurt
each
to
of-
make it null. I don't know. Sorry.
Wait, hold on. What is she? This is her code from the thing directly.
Yeah.
The one that's written. Okay, then then you're
Yeah.
right. Then you're right. Because, right here it should be head.next.
Yeah, that's what I was confused about.
Yeah, no, you're right. Right. In her code, she does, head.next.
And then in the while loop, it's while current isn't null.
Oh.
So current.next.
Yeah, well-
next, yeah.
Yeah. While current.
And
You can
oh, you could
If-
get rid of that if statement and just put an and in the while loop.
No, you can't get rid of this if statement.
Yeah, because in the while loop you could do while current isn't null and current.data isn't equal to x or whatever you're looking for.
Wait, what is it?
Yeah, I get what you mean. So like, and this isn't true.
Yeah. Yeah.
It's return true. Wait, I have a question. Was your search for the table, adjacent table? Wait, what did you put Boolean array?
Are you asking me?
Yeah. What does that mean? What's the parameter?
What, Boolean?
No, I see the parameters Boolean bracket array.
So you pass in the list that you have. U is, I guess you could consider that the first vertex you're looking at, or like, yeah. So you're checking if something exists from U to V, so like A to B or C to D.
Yeah, so
For that, whilst
that represents a list. Boolean.
Mm,
That's the adjacency list.
yeah, Jason.
Fuck, man. Oh my god.
oh, this is adjacency list.
No, this is adjacency list with valence. So that's
Money
the
with
list array of lists.
no, like what's the search for?
The valence one.
Oh, okay. Oh, I thought this was hash table. Okay.
Is it not still hash table? This looks very familiar to the hash table.
It is. That. So the hash table and the adjacency list with valence,
Yeah.
the chaining one for the hash table, it's like the exact same code.
But when do we return true in this case?
This is checking if it's true or not.
Oh, okay.
This is the code that she wrote. So what it's doing is if you found the data, you'll leave the
Yeah.
while loop and your current will be pointing to something. So it's saying if your current isn't pointing to anything, that means you didn't find it. So return false here.
Okay.
Can you go over the find min also, just for this one?
Okay. So we're it's the same way we would do it in any other array. We're gonna just set it to the first element. But you have to do dot head dot data. And then same for loop. It's less than.
Wait, isn't the head no? No dot data doesn't make sense.
I think I messed up on that. I think it should be head.next.data.
Head dot next dot data. Okay.
Wait, isn't it not what's before the head that's null, not after? Because if head equals null, then the whole thing would just be empty, would it not?
Yeah, I think you can take care of that by doing like the if is empty thing before all this.
Yeah. Well, no, head could be null and still be pointing to something.
Yeah.
Okay.
Yeah, head.next.
Is a dumb me nope.
Right.
Dot head dot next. So, I mean, I think it's pretty self-explanatory, but in this for loop, you have an array and you're going through the array. You're visiting each thing. each thing is like looking something like this. And you're saying while current, you're setting your current to head.next. So instead of this is what your head is pointing to, you're moving your head to down here. Head.next. Actually, the head. This I'm assuming this is empty right here.
Yeah.
And this is your first element. So not this. That's your first element. This is what your current is pointing to. If the data that is stored in current is less than the minimum, set it to the minimum, and just keep doing current.next. So then you're gonna go over here. The for loop is gonna I is going to equal to 1. So you're gonna move over to this one. You're gonna keep repeating that over and over again. And you're gonna find your min. You're just gonna return min.
Would you pass in the head into the min function or no? Because like usually like in these like functions, aren't you passing something in to like access it?
You are. I just didn't write that part.
Oh, okay.
You didn't write it.
Wait. A sub 0 is supposed to be like. Wait, no.
Yeah, so it's still a linked list. So I mean, it's still an array. So you're gonna start with this first element right here.
Okay, then you compare with other elements in the same list, and in the same
in this same thing, you're gonna have something else that's pointing up here like this.
Okay.
Pointing up here like this. So it's gonna go first to a sub 0. You see over here it says a sub I. So a sub 0 is gonna be first, then a sub 2, then 3, then 4.
No, so shouldn't you like, no cur should be a sub I dot head dot next, because you're comparing, like your first comparison will be like itself to like.
No. Over here, you're talking about this for this second line.
Yeah.
So what we're doing over here is we're just picking any element, and we're setting it to min.
Okay.
You know how like in like a regular array, if you have like this and you have 1, 2, 3, 4.
Yeah.
And you want to find the minimum, you'll set instead of setting min to 0, because you don't know if 0 is actually going to be inside this array. You just set min to a of 0 instead.
Okay.
Which is 1. You could have also done 3, which would have set it to 4, and then you do the comparison against that variable.
But the no cur, like the first comparison, will be to itself, right? Because of
Yeah.
Yeah. That's fine.
Okay.
It will be to itself. Yeah, you're right. It's gonna compare a sub 0 to a sub 0.
What does it return if it does that? Because it's the same thing.
This if this if statement doesn't run, you just do current equals current.next. You move on.
Oh, I see. Okay.
So if this had 1, 2, and over here you had 3, 4. In this situation right here, 1 is the smallest, right? So it's going to compare 1. See, is 1 smaller than 1? It's not. It's going to keep moving on. But min has been equaled to 1. So after all the comparisons, nothing is going to be 1. So at the end, min is going to remain 1, and you're going to return 1. That just means that the first element that you picked to min to be, that already was the smallest element.
And max is just basically like switch min to.
Max is the same thing. You just switch.
Yeah. Doesn't. Like max, you just need to change two part int max, and then you have to change the if statement where you do like it should be bigger than max. I guess yeah. Please let this one show up on the final.
No.
I don't want to remember some vertex or edges.
No, cause I'm looking at adjacency list right now. I don't. Wait, why is it a for loop? For loop is nothing but the neighbor equal to the bed is return true.
Yeah, I don't get it either. I just copied what she wrote.
Wait, that she wrote that? Wait, what?
Yeah.
I thought it was another while. But this is a linked list. This is not a linked list, the adjacency list? What the fuck is the adjacency list look like, bro? Jessica. 2D array 2?
Oh fuck.
So over here you have a linked list of integers that are neighbors, and you have a list of you. You're just doing a for loop over the list. You have neighbor.size to get the size of that list, and you're saying neighbors.getI. So you have a function called getI. You're comparing it to the value v, which you have over here. If you have v in it, you're just returning true. If not, you're returning false.
Wait, what is this for? Is this for search?
Wait, this is the search, right?
For a linked list?
Yeah, you're searching for variable v.
Okay, I found another snippet of code that she gave that makes way more sense. I'm gonna send it in the chat. The one I just sent makes more sense because it's actually a linked list.
Yeah, it's the same thing. You're checking to see if that data exists.
Yeah.
L is referring to
L is the list.
Yeah.
L is the list.
Wait, watch. Are you like the 915 class?
No, I'm in the
1045.
Yeah.
All right, let us know how you do tomorrow.
Yo, it's over, bro. It's finished.
It's okay. We'll be on our knees too, bro.
Yo, I don't want to ask her for the 5 points she still owes for the Zai books.
God damn.
For the midterm.
No,
She got really pissed when someone asked last time.
Yeah.
So she apparently for that she's going to add it separately because Brightspace doesn't allow her to add it to the midterm itself. So it'll be 105 as total instead of a +5. So she'll do it last. That's what she said last class.
Oh, she gonna forget that shit. Her internet gonna break, and grades are gonna be due.
Yeah. We just gotta keep reminding her.
Yo, I got a question.
I hope her dog like eats the bag that has all the finals in it.
Nah, it's crazy.
I was wondering if both
Yo,
sections.
surely like somebody can catch her before she gets into the exam room and take that shit.
Bro, I'm dead ass.
I need Jeff Bezos to like make Amazon go out of business and like her printer breaks in the same day.
Nah, someone poke a tire in her car, bro.
For real.
I don't feel comfortable with these fucking adjacency shits, low key. Like if
Yo, dead ass. I don't want that shit on test.
you ask me about to write this shit down, I'm like, oh, fuck you, bro. I'm not gonna do this shit. I'm gonna forget something really important, and then, like, the whole code doesn't work like that. Not
Nah, I had one final where the fucking the professor teach me like quiz me on the only thing I did not like, remember. That so bullshit when they do this shit, man. Like you remember everything else except they quiz you on fake stuff.
That's what happened to my Calc 2 final. I studied everything except solid revolutions, and half of my final was on that topic. I barely passed.
No one has any of her like past finals or anything, or no.
No.
No, she straight up was like, no, fuck off. I'm not giving you.
No, she hasn't taught 313 in like how many years?
Holy shit!
Oh,
That's why there
Did
are
she
no
not teach it last
final.
year?
Nah.
No, I mean that's what she said herself. She said she hasn't teach it in like 10 years or something.
Bruh.
That's crazy.
Oh, she not qualified for this.
She was like, everybody kept failing like the higher level classes, so she wanted to teach 313 so she could ensure that every student is ready for the higher level classes.
She wants to do it herself. Oh,
Now, word, she took it into her own hands to fail everyone if they aren't ready.
Well, she did a pretty bad job at it. I still don't feel good with some of these.
What do you mean she's not trying to fail us, bro? She's
No, no,
trying
no.
to fail us.
No. I never said that she was trying to help us succeed in the higher level classes. I said she's trying to fail anybody who's not ready for them.
Oh, okay, yeah.
Which she's
she
doing
just
a great
doesn't take
job
any
at.
prisoners. That's the thing. It's only a issue.
Well, we can figure out the final harder classes when we get to it, bro. Just let us pass.
Bro, Dad, she's doing the Daniels. Fine, I'll do it myself.
Exactly, like with that, I'll do it myself. Nah, because like it's funny because like all I need to do is like if Anne passed me for 313, I can hopefully take Chin for 323 and 331, and I can pass easily. I can pass with Chin no problemo.
Yeah, I love Chin.
Yeah, I love her too. The peak CS mommy, bro, the real one.
Bro, she gave me so much questions to review. What does Annie give me, bro? Zybooks?
No, for real, I hate that shit.
Yo,
Like,
and I
if
swear
Chin-
the Zybooks, like we would be doing something in class, like one thing in class, and the Zybooks is like 3 weeks ahead.
I know.
Mm-hmm. Also, like Chin literally does like a review session the class before the exam.
Yeah.
And she'll like before she gives the exam, she'll literally take some questions.
Bro, she'll literally give you the exact format of the exam, bro.
Exactly. Yes, exactly.
Yeah, Annie over here talking about everything. She wrote everything on the paper and she did something.
Mm,
did you guys get good professors for next semester?
something like that.
Bro, good professors don't exist next semester, bro. They're either all filled or you get or like you get like waitlisted to like 9th seat or some shit.
I'm still on seat 8 for Chin. It's so bad.
I'm waitlist on both of Chin's sections, please.
For 331?
Yo, don't worry, bro.
Wait.
Someone's gonna fail 313.
Yo, dead ass.
That's crazy.
Please. I'm sorry, but I need this class. I need Chinny.
I'm about to be all Gen Eds next semester if I don't get any CS classes.
Well, I only have CS classes. I'm cooked. I don't have no other fucking like gen eds to complete.
Oh my god.
Algebra. Oh my god. I'm cooked.
Hear me out, get a minor.
My worst nightmare.
Like it's actually the worst nightmare. I actually regret this so badly.
Wait, linear
No,
algebra is
what you
not that
gotta
bad.
do- You got a minor in something like in humanities, like drama. There you go. You
Yeah,
have your
true,
gen
So under my GPA would never fail.
Yo,
Nah, easy major, minor.
like anything other than like I feel like every single major in history are like not major. Every single class in history is so like easy A's. Like
It is. It really was.
Is this it? I mean, What are you guys gonna do? Like all nighter or like what?
I'm about to go take a sleep and review 231, bro. I'm cooked.
What you mean, bro? You got the past 2 finals in the review. Get on that. Get to it, bro. Get to it.
I'm cooked, man.
How'd you do on the first 2 exams? If you did fine, you don't need that high of a score.
For what?
231.
Got like around 40s.
Okay, then you shouldn't do bad. You're fine.
But I want to get an A.
And then review. Get to it, bro. Sacrifice
Yeah.
your sleep.
No, if I sacrifice my sleep, nah. One time I put like an all-nighter, and I took, and the next day was the final bell. I'm seeing some fucking hallucinations like during the fucking test, bro. I'm looking at like a 2, like a 3, and then the rest is history, bro.
Were you hearing the voice?
All nighter is too much, but like at least like stay up a little bit if you really want to study.
Yeah.
All right, guys, let's do something else then. Let's somebody else stream, bro. Somebody do something.
Nah, I'm gonna go to bed.
I know we collectively know it all.
No.
We try to learn Morse code. We can like share the answers during the test.
Yeah,
Oh,
true,
wait.
true, true.
Come on, someone hop on. Do they have Morse code on Duolingo?
I mean,
What?
I feel like we all posted at least a little bit of everything on the general chat, so we all have like a good understanding.
Wait. I think we should compile all the useful notes together.
Alright, you got that right.
Whoever
I just think
sent
everything.
whoever sent that final review PDF, that's like perfect. It has everything on it.
Yeah, true. Whoever sent that.
It has everything. It has runtimes. It has implementations, search algorithms.
To just read that, reinforce our already existing knowledge, and we're good. Hopefully.
Bad.
But no, I can't wait until finals are over, low key. I'm like,
Mm-hmm.
I am in like, I don't know, bro. I am so ready to just pass out. This one has to mess up.
That's not Greg Cook.
I thought you guys were writing something else.
What is the runtime of Cook?
Let's do a little quiz on runtimes, guys.
What was her dog's name? I'm trying to remember. What was her dog's name?
Why you
Her dog name was Data, I think.
Data?
No way.
I'm joking,
It's actually like a name of a dog.
I was about to say. No, she said it. It was a W name. It was something with a W, I feel like. Was it Winston?
No, I don't think it was Winston.
It was something with a W.
What's your name? Yeah, no. So guys, no. Let's do some runtimes real quick. Fuck, I don't even know how
we are.
binary something. What insert into like a. Oh shit, bro! I'm cooking.
All right, so what's the runtime of an array?
It's O of N.
That's.
See,
It's
I was
O
gonna
of one,
ask
bro.
about best case. I was gonna ask best case, and now you're wrong.
No, it's O of one. O of one is best case. Am I right?
Oh yeah, true.
No. But he replied for worst case.
Oh, okay.
Oh, that's the name Murphy.
Murphy. Oh yeah. Shit.
Okay, so best case is O of 1, and worst case is O of n, right? And average case is also O of n, right?
Yep. Do you know why?
Yeah.
Why?
So average case is O of n because n, like, depending on how many elements are, and worst case is O of n because depending on how many elements there are in the array, you need to go through the array that many times. And then O of 1 is best case because if you're looking for something specific, then you can just get that, right? Or I forgot.
Okay.
If it's the first element, if it's the first element, then it's O1.
Oh yeah.
Or
yeah. Or if it's just the
for-
last element, then you could just return the length, index length -1. So yeah.
we're still talking about arrays?
Yeah. Are we? I don't know.
Yeah, we are. It's a lot simpler than that. It's basically the first element that you search might be the one you're looking for. So best case, you find it on the first one, it's O of 1.
Yeah.
Worst case, it's the last element, which is O of n. That's it.
yeah,
That's
and-
all there is to it.
Alright. Well, what about let's do some heaps. Heaps. Best case.
Yeah, heaps insert worst case.
Worst case.
Heaps insert worst case is O of n, is it not?
No.
I thought it was n log n or something like that.
Also no.
It's log n, 100%.
It's log n.
Log n. Do we know why?
Nah.
No, I really don't.
No.
Nobody?
We just.
My bad. I was guessing.
What? Oh, for some reason, the depth of the tree is log in and all. If you want to find something, it's an element within this. Go right, go left, so on and so forth. Log in. So like your average binary search tree, right?
So
Wait, that means like it's like the depth is not changing, right?
for ABL tree, did I say ABL? Did I say heap? I said heap, right?
The ABL.
You said heap. No, he said heap.
I said heap.
Oh, why you lying?
Wait, me?
For-
Is it different? Because they're both binary searches, right?
For a heap insert, the reason why it's log n is, let's say it ended up being like let's say it was a max heap, and you were entering a min, and your worst case scenarios are down here, right? But regardless of which way you go, you're going to be splitting your elements in half. So it's getting smaller and smaller each time. So at first you're comparing against the left side and the right side, but you're splitting it in half, and then you're comparing against this side, and then you're comparing against this side. That's what makes it log of n, if that makes sense.
Alright, so essentially anytime we're splitting or anything like dividing or
Yep.
halving, we're just log n.
Yep.
That's the best case.
No, that's worst case.
Oh, worst case.
I mean, let's do it with some numbers, right? Let's say this is 30, and this is a max heap, right? So this is 12, this is 8, this is 7. Yeah, let's just leave it at that. Actually, no, we'll put 6 here. And let's say we're entering the element 2, right?
Yeah.
First comparison is going to be between 2 and 30. 30 is obviously greater. We're gonna disregard everything on the left side. We're gonna move to the right side. We're gonna compare it with 12. It's less than. We're gonna put it right there. So we've only done 2 comparisons, and we never compared it with 8, 7, 6. So we essentially split our data in half, and this just keeps happening every single time.
Okay.
For a best case of the heap, it's O of 1, because
the first element.
Yeah, this could have been empty, and we could have just put 2 right there. So that's the best case.
Wait, why do we like disregard the other side first?
What's up?
Why do we disregard the other side when we
Is it because
Because there's no room there.
Oh, okay.
So there's no. We just. This is a min heap, right?
Yeah.
Actually, no. I explained it
Oh,
completely
you said
wrong.
max.
I said max heap, right? Yeah, I explained it completely wrong. We're gonna just put 2 here. We're gonna compare it with 12. Is 2 less than 12? It is. And then is 2 less than 30? It is. So 2 does belong there, and that's it. That's all we have to check.
this is the one where we just shove an element into like wherever whatever's at the bottom, and then we compare it. If
Yeah, exactly.
it's transparent, swap to compare to the next parent, and then do it again.
Yep. Like let's add another number. What number you want to add?
40.
Okay, sure. We'll add 40. So here, we're just gonna add 40 wherever it's next free. Had there already been a 40 here, we would have put it right here.
Yeah.
We added 40. Now we're gonna compare 40 and 12. Is 40 larger than 12? Yes, it is. So we're gonna swap these elements. So this over here is gonna be 40. This over here is gonna be 12. And then we're gonna compare again. Is 40 larger than 30? Yes, it is.
Yes.
40 changes to 30. So we were able to put it in the right location with just 2 checks, as opposed to checking everything else. So we didn't even look at the left side because we just didn't have to look at the left side.
Wait, so
That's why it's log of n.
this is the worst case?
This is worst case, yes. For an insert on a heap. Best case is
1.
Best case is you enter it in the right spot to begin with, and there's no changing whatsoever.
Heap is just it's just 1, right?
Yep, like when we entered this 2, that was best case.
Yeah, there was no issue. Alright. Yeah, but I'm gonna go to sleep. Good night. Like, on God, I'm tired as fuck. Like, I feel like I have retained no information if I don't go to sleep.
Yo, that ass.
That's so fair. Go to sleep if you need it.
Good night, gangsters. Good luck with that.
Have a good one.
I know.
Yeah.
Bye
Love
bye.
you too.
I'm gonna go suffer tomorrow. I'll try my best to remember anything that happened after that final.
Yes.
In the chat. But,
Yeah.
When then the stick to live.
Yeah, I think we'll call it here.
Alright.
Alright.
Hope you guys do good. Good luck,
Have a good
guys.
night.
Good luck, everyone.
Good luck.
You too.